Live lesson. Number 1, solving equations. Giving myself a red mustache. Okay, that was dumb. All right. Problem 1. We've got ourselves a 2-step equation. And A is not all by itself. I have to get A all by itself. So I have 2 things that's going on with A. I have divided by 4. I have plus 2. You use reverse PEMDAS whenever you're trying to isolate a variable. So the first thing I'm going to do is reverse PEMDAS, also known as SAD-MEP, which is how I feel. SAD-MEP. SAD-MEP for Mr. P. Okay. -2. Nothing's changed. -2 from both sides. 6 minus 2 is 4. And I have A over 4 left over. Now I want to get A all by itself. And the way I get A all by itself is I do the opposite of divided by 4, which is multiply by 4. Multiply by 4. Cross that out. 4 times 4 is 16, the legal driving age in Pennsylvania. A is 16, but I hate the way that looks. A is 16. Yay! Problem 1, finito. Thumbs up to my friends on Instagram. There's like 80 people on Instagram and nobody doing what they're supposed to be doing. Congratulations, children, internet world. All right. Problem 2. I am pretty much the same exact problem as the last one. I'm really not creative there. Very similar. I have -5 in the way, and I divided by 20 in the way. So what I have to do is I have to get R all by itself. R is not all by itself. Divided by 20 is in the way, and -5's in the way. What I have to do first is get rid of the -5. And the way I get rid of the -5 is I add 5. Add 5 to both sides. -4 plus 5. I owe $4, but I get $5. I have $1. Real life. But if you're only getting $5, you need a better job. Thank you, whoever chuckled in the background. R divided by 20. Let me see. What do? I get rid of 20 by multiplying both sides by 20, just like the last problem. Multiply by 20, multiply by 20. 20 times 1, carry the 1, 20. 20 equals R, but I hate the way that looks. R equals 20. And those of you who are just go-getters who want to really check your work, you can just take that 20, plug it into R. 20 divided by 20 is 1. 1 minus 5 is -4. Looky me, I did it right. Yay! All right. I'll let that breathe for a second, because I'm sure the hundreds of people viewing on Instagram, nope, just 10, are taking notes. Ooh! Well, when I had a 10 being multiplied to a parentheses, and inside the parentheses I'm doing more than just nothing, I'm adding or subtracting or more, I take a little thing called distributive property. And distributive property is when I take the number in front of the parentheses and I multiply it to everything inside the parentheses. So I have 10 times K, 10K, like 10 kittens. And I have 10 times -9, so that's -90 minus 90. And I drop down the -10. All right. So is K all by itself? No. What's in the way? 10 in front of it. 10's being multiplied. Got to get rid of that. -90 is hanging out. Let's get rid of that guy first. So I'm going to do the opposite of negative or -90, and that's going to be positive or add 90. So I'm going to add 90 to both sides. I'm down $10. If I add $90, I now have $80. That's much better than the add $5 problem from before. That's going to equal 10K, how much I make in a week. 10 is being multiplied to K. So I'm going to divide both sides by 10. divide both sides by 10, cross u out. 8 is equal to k. Ooh, but I hate the way that looks because 8 is on the left and k is on the right. So I'm going to make it k equals 8. And again, those of you go-getters who want to check your work, plug the 8 in for k. 8 minus 9 is -1. 10 times -1 is -10. I'm sure you all tracked exactly what I did there. And you're like, yeah, I gotcha. But that's the third one. I think we're gonna do 7 problems, and they increase in difficulty as we move along. I am gonna post this on YouTube, and I'm gonna save, as long as Instagram lets me, I'm going to save this on my stories, but that only lasts a day. But I will put this on YouTube. All right. Let's see what I have here. I have an 8x on the left minus 2 equals -9 plus 7x on the right. So I have an x on the left and I have an x on the right. So this is one of those balance beam problems where if x represented xylophones and you wanted to weigh a bunch of xylophones, you would put 8 xylophones on the one side and 7 xylophones on the right side. And then someone will come by and be like, why do you have all those xylophones on the balance? And you're like, I don't know. It's a math problem. And then they suggest that you remove a bunch of those xylophones. Well, what's the largest amount of xylophones that you can remove from one side of the balance? Well, this side over here on the right has 7. So if I get rid of 7 xylophones on the right, that's going to tilt the balance. So how do I even that balance out? Do the same thing on the left. So if you have a variable on the left and a variable on the right, not variables on the same side, if you have a variable on the left and a variable on the right, what you see, or what you should do, is get rid of the smallest one. And in this case, the smallest one is the one on the right. Some people like to always get rid of the one on the right side. It doesn't really matter. And I might switch the rules up later on because of the problems that I know we have ahead, but we'll see. If I have 8 xylophones and I take away 7 of those xylophones, I now have a xylophone, 1x, or just x. Drop down the -2. That's an ugly 2. Drop down the -9. Is x all by itself, you ask? No, I say. How do you get rid of -2, you ask? Well, why don't we do the opposite of -2? And that's +2. See? -9 plus 2, negative's bigger. So if I add the 2, it's going to stay negative, but you subtract the numbers. -7 is the answer for that. Okay. 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 A few more. Well, I have a pineapple on the left side of the balance, and I have a pineapple on the right side of the balance. And somebody comes by and says, why you have all those pineapples on the balance? Get rid of some of those pineapples. And so you say, let's get rid of that pineapple right there. But then the balance tips. And then you're like, oh, then I'll get rid of that pineapple right there. And now the balance is even again. And then that goes away. And if P minus P goes away, then doesn't P minus P go away? And you have -4 equals -9. Oh my goodness. The variables disappeared. What kind of world is it that variables disappear? Well, they did. Because if you remove a P from the left, you have to remove a P from the right, and that takes all the P's away. No more pineapples for you. But I have -4 equals -9. Let me see. Let me get my calculator out. Does -4 equal 9? It doesn't. Goodness me. Well, that can't be. It looks like there's no P value that I can plug a number in and get an answer. So I'm going to write in red letters, no solution. Now we're even. See, it's no solution because the variables disappeared. And if the variables disappear and you get a math statement that doesn't make sense and -4 equals 9 is not true, it's a no solution. If it was going to say -4 equals -4, then it would be infinite solutions. And I'm going to say that because I know we don't have an infinite solutions problem looking forward. So if the variables disappear and you're left with something that's a lie, no solution. If your variables disappear and you have 4 equals 4, that's infinite solutions. When we get to chapter 5, there is a little poem that somebody wrote that should be published in like the New York Times that'll help you remember to do problems like that. Forget who wrote it though. Really smart literary person. Something about intersecting. I don't remember. All right. Oh my gosh. So I wasn't lying. These problems do get wackier. So let's just do it. I have distributive property right away. So let's do distributive property. -3 times 4x is -12x. -3 times +3 is -9. Distributive property once. Now we have a +4. I was going to say +4, and it is +4, so I'm not wrong for stuttering there. 4 times 6x is plus 24x. 4 times 1 is 4. And all of that equals out to 43. Now, before you go crazy and say, oh, I know what to do. We have a -12x and we have a 24x. Let's do something to both sides with those x's. Oh, no, 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 no. Those x's are on the same side. And if the x's are on the same side, you're not going to do something to both sides because they're on the same side. That's like saying I have -12 x's, or I owe $12 and then blah, blah, blah. And then all of a sudden, oh, I get $24. You're just going to combine them. And if you have -12x plus 24x, that leaves you with 12x, because it's the same way as saying, it's the same thing as saying 24x minus 12x. So I do combine those. And also I combine these guys because these guys are just regular numbers. Oh. So -9 and +4 is going to be -5. Similarly to the last problem where we had, or maybe it was the problem before where we had a negative number and we're adding a smaller positive, you still subtract those numbers, but you keep it negative. That equals 43. Now it looks like a regular two-stepper. My favorite type of country swing dance. Ha ha ha. Oh, being alone. Although we're never alone, aren't we, kids? Because of... forget it. If I have -5 and I need to get rid of -5, I have to do the opposite of -5, and that's +5 plus 5. If I add 5 to both sides, I get 43 plus 5, which is 48. My Instagram live is now down to 4. Do a better job, children. Stay focused. 12x equals 48. I'm going to divide both sides by 12. Why am I doing that, you ask? Well, x is not all by itself because multiplied 12 is in the way. So if I divide 12, that makes u go away. And 48 divided by 12 is 4. So x equals 4. And just like all the other problems, you can check these by plugging in 4. And you would have a little bit more math to do. But, you know, that is your possibility. Plug in 4. And I'm just going to do it in my head. Yep, I did it right. Okay? Okay, I think we have one more to go, I think. And if I move to the next slide, if that 8 is shaded, I think that means I'm done. Hey, last problem, kids. Oh my gosh. Oh my gosh. That's like an Algebra 2 problem. Well, it is. In fact, I got all these problems from a website that makes free worksheets. Some of you know what I'm talking about, but I don't want to say the website because unless they give me money, I'm not going to help them. But, you know, these are all Algebra 1 and Algebra 2 problems. So if you're like, oh, wow, I understand these and I really need a pat on the back, well, pat yourself on the back. Those of you who are still watching, all, I think it's 3 of you. So I'm going to distribute. -5 times +1 is -5. Be very careful. -5 times -5x is +25x. Okay? You're distributing the -5 to both things. Now I'm distributing a +5 to both things. +5 times -8x is -40x. 5 times -2 is -10. And that's going, let me choose a different color. That's going to equal -4x minus 8x. All these x's here. What is it, my high school reunion? Couldn't be further from the truth. Now on the left side, I have a -5. I also have a -10. I'm not going to do stuff to both sides because they're on the same side. So if I owe $5 and all of a sudden I owe $10 more, I now owe $15. Okay? Similarly, I have a 25, and that's a positive 25x, minus 40x right next to each other. So I'm not going to do stuff to both sides because they're right next to each other on the same side. So if I have $25 and I owe then somebody $40, I am now down $15, 15x. Okay. On the right side, I have the same thing going on where I have -4x minus 8x on the same side. Before you think, let's do stuff to both sides, combine them. -4x minus 8x is -12x. Now what I have, and it's a mess, but the rules still apply to the problems that we did before. I have variables on the left and I have variables on the right. I have a -15x on the left and I have a -12x on the right. What I want to do is I want to get rid of this guy right here. And the reason why I'm going to get rid of that guy and not the one on the right side is if I move the -12x to the left, then I have two things on the left. But I know if I move that -15x to the right, that -15x, if I add 15x, is going to go away. And so when I drop things down, I have -15. So if I add 15x over here and I drop things down, -12x plus 15x is 3x, and the rest of the problem is not so bad. Divide everything by 3, divide everything by 3, cross you out. And I'm going to flip sides while I'm at it. X is going to equal -15 divided by 3, which is -5. So basically, what we just did is pretty much all the problems that you would see in Chapter 1. They're not going to get much crazier than that. We didn't do any word problems, but, that should cover Chapter 1 pretty well as far as the mathy stuff goes.